you've been told to obtain the value of t, for which t plus 1, t minus 5, and t minus 2 is a geometric progression, isn't it? Hence, obtain the sum of the first 10 terms. So if this is a geometric progression, all you need to know what is the first term over GP, isn't it? The first term over GP is denoted by A, isn't it? So if these are terms of a geometric progression, then you simply do it like this. If you have the first term, second term, and the third term, so the first term you've been given here is t plus 1, isn't it? Meaning that A is t plus 1. The first term is t plus 1, the second term is t minus 5, and the third term is t minus 2. When you know that, the first term times the common ratio gives you the second term, isn't it? Then the second term times the common ratio gives you the third. Are you seeing that? So you know very well that first term times common ratio, t plus 1, if you multiply by r, you get t minus 5. Are you seeing? Are you together? Then at the same time, t minus 5, if you multiply by r, t minus 5, if you multiply by r, you get t minus 2, isn't it? Yes. Are we together? So from there, so you make r the subject of the formula and you equate the two equations. Yes. You make r the subject of the formula. So in this first equation, it implies r is t minus 5 over t plus 1. You divide both sides by t plus 1, isn't it? Yes. And in this second equation, it implies r is t minus 2 over t minus 5, isn't it? Isn't it? So you made r the subject, so equation 1, equation 2, then you equate the two equations because r is the same, isn't it? So if you equate the two equations, you get t minus 5 over t plus 1 is equals to t minus 2 over t minus 5. So you now solve that given equation to get the value of t. Are we together? You solve that equation to get the value of t. Can you solve that? You just cross multiply, isn't it? You cross multiply, so if you cross multiply that, t minus 5 times t minus 5 times t minus 5, that is t minus 5 squared, isn't it? T plus 1 times t minus 2, you get that, isn't it? So, can you factorize? Can you expand either side of the equation? You expand, isn't it? So if you expand t minus 5 squared, that is a quadratic identity, a minus b squared, isn't it? You get a squared minus 2ab plus b squared, meaning a is t, b is 5. Well, then you say you put t, so you get t squared minus 10t, isn't it? Yes. Then b squared 5 squared plus 25, isn't it? You've expanded that perfect square, isn't it? Using a quadratic identity. Then you go on the right hand side of the equation, t squared times t is t, t times negative 2 is negative 2, positive 1 times t is plus, positive 1 times negative 2 is negative 2, isn't it? So you can see t square cancel out on either side of the equation, isn't it? Isn't it? So what do you remain with? This side you have negative 10 t plus negative 2t plus t is negative t, isn't it? Minus 2, isn't it? Yes. Are we together there? So, can you simplify? Negative t coming this side, positive t. So you get negative 9t. Positive 25 goes to the other side is negative 25. So you get negative 27, isn't it? So for you to get t, you divide both sides by negative 9. You get t to be 3. After getting t to be 3, you are told to find the value of t first, isn't it? Then after obtaining the value of t, you are told hence obtain the sum of the first 10 terms, isn't it? So for you to get the sum of the first 10 terms, it means, first of all, we found our t to be 3. Let us record that. So, if t is equals to 3, what is A? The first term. A was the first term, which is t plus 1, isn't it? So it means the first term is 4. Then we look for R. Here we have the first term, the second term there. What is the second term? So this is first. The second term is t minus 5, isn't it? 3 minus 5. You get the second term is negative 2, isn't it? So the first term and second term alone is enough for you to get R, isn't it? Isn't it? Yes. Because you know the second term is AR, isn't it? So AR is equals to negative 2. So for you to get R, you divide by the first term, meaning R is negative 2 over the first term. R is negative 1 over 2. So negative 2 times negative 1 over 2, you get the third term to be 1. So you can confirm t minus 2, t is 3. 3 minus 2 is 1, isn't it? So you found there, A goes with A, you found R is negative 1 over 2. So what we need is the common ratio R and the first term A, isn't it? So A is 4, R is negative 1 over 2. So the sum of the first 10 terms over GP S10 is given by what? A into R raised to power n minus 1 over R minus 1 or A into 1 minus R raised to power n over 1 minus R, isn't it? So whichever you use, you get the same answer, but they do normally say you use this case when the absolute value of R is greater than, and you use this case when the absolute value of R is less than 1. But the answer will be the same. It's only that they are trying to tell you when the absolute value of R is less than 1. It is easier to work with this because you will not get a lot of negative numbers, isn't it? Because you end up with negative this over negative this and negative cancels out such cases. Are you seeing? But whether you use this or this, you get the same answer. Are you together? You get the same answer. So can you work out that? Work it out. You have the first term A is 4 and R negative a half. So give me the sum of the first 10 terms. So the sum of n terms is A into 1 minus R raised to power n over 1 minus R, isn't it? So S10, when n is 10, what is your A? 4 into 1 minus negative a half raised to power 10 over 1 minus negative a half. 1 minus negative a half is changes the sign to plus, isn't it? Isn't it? Yes, this is supposed to be 1 minus negative a half, which is 1 plus a half. What do you get? What do you get with the sum of the first 10 terms? 128, isn't it? That was 1023 divided by 3. 1023 divided by 3. 1023 divided by 3. 3? Yes. So you see that calculator is bogus, isn't it? So what do you have? 3? 341 over 120? 341 over 128. Confirm that.